Hello students, so in this question we have a circuit provided to us. So this is a circuit that has a applied potential of 24 volt and we have 4 resistors whose resistance values have been provided to us. Let us assume that the total current flowing in the circuit is I. So here it also will be equal to I, and let us assume that the current flowing through this is I1, this becomes I2, this becomes I3, and this is equal to I4. So in the first part of the question we are asked to find out what is the net resistance or total resistance of the circuit. So we can see that R1 is parallel to R2. So if R dash is the total resistance of R1 and R2 resistances which are in parallel to each other, then we can say that R dash is simply equal to R1 multiplied by R2 divided by R1 plus R2. So that is equal to 250 multiplied by 100 divided by 250 plus 100, that is in ohms. And making this calculation we get this to be equal to 71.42 ohm. Similarly we can see that R3 is parallel to R4, and if R double dash is the resistance of these two parallel combination of resistors R double dash, then this will be equal to R3 multiplied by R4 divided by R3 plus R4, so that is equal to 200. So this is actually multiplied by, we're going to change this right now. It would be multiplied by, instead of adding it, whole divided by 200 plus 350 ohm, and this calculation comes to be equal to, this one becomes equal to 127.27 ohm. So now we know that R dash and R double dash are in series. So if R net is the total resistance of the circuit, then this will be equal to R dash plus R double dash, that is equal to 71.42 plus 127.27. This is in ohm, and this we get to be equal to 198.7 ohm. So 198.7 ohm is the total resistance of the circuit. Now in the second part of the question we are asked to find out what will be the total current flowing in the circuit. So we can say part B. So part B is actually 0.2.2 and part A is 0.2.1. So we will say this to be equal to 2.1 here. So the total current flowing in the circuit I is equal to the total applied potential by R net. So it's 24 divided by 198.7 ampere. So the total current flowing in the circuit is equal to 0.120 ampere. This is the total amount of current that is flowing in the given circuit. Now in the third part we are asked to find out what is the voltage across the 250 ohm resistor. In 2.3 we need to find out the voltage across the 250 ohm resistor. So we can say that V1. So we can see the 250 ohm resistor. If we see the diagram here, the 250 ohm resistor and the 100 ohm resistors, they are parallel to each other. So the potential difference across them would be the same, and this potential difference will be equal to the total current I multiplied by the resistance R dash. Now I'll explain to you why this is like this, because see, if we see the diagram here, we can see that the two resistances are parallel to each other, and for parallel we know that the potential difference, we know that for parallel combination, the V is constant, right? And we know that V is equal to IR, right? And the total current that will flow through this entire circuit, will be equal to I, because I1 plus I2 is equal to I, and here R dash is the net resistance of the R1 and R2 connected in parallel. So we can find out what is the total applied potential difference across this circuit, across this entire circuit, and this will be the potential across each of the resistances. So that is I multiplied by R dash, so this is equal to 0.120 multiplied by 71.42 volt, and this we get to be equal to 8.626 volt. 8.626 volt. Similarly, we can find out the voltage across the, 2.5, we can find out the voltage across a 200 ohm resistor. The voltage across the 200 ohm resistor V2 would be equal to the total current multiplied by R double dash, because we need to find out the total voltage in the circuit. In this second circuit, if we find out the total potential, this will be the potential across 350 and 200 ohm resistances equally, and the total potential here is equal to the total current, that is I, multiplied by the total resistance, that is R double dash. So putting the values again, we get here, this is equal to 0.120 multiplied by 127.27 volt, and this we get to be equal to 15.372 volt. So this will be the voltage across the 200 ohm resistor. Now we'll move on to the final part of this question. In the final part of the question, we are asked to find out what will be the current flowing through the 250 ohm resistance. So we can say the current flowing through the 250 ohm resistance, if we assume that this current is I2 as we showed in the diagram above, that this is current I2, then using the current division rule, so we can say using current division rule, we can get that I2 would simply be equal to I multiplied by 100 divided by 250 plus 100. So we get the value of I2 is equal to 0.120 multiplied by 100 divided by 350 ampere, and this is equal to 0.0345 ampere. 0.0345 ampere. So this is the current that is flowing through the 250 ohm resistance. So we found out the answer to all the 5 bits of the question. Thank you.